Okay, so hi everyone, welcome. We are just waiting for a minute to other people to join, and then we are starting the webinar. Yeah, I think we can start now. Okay, so hi everyone, and greetings from Shiksha Online. This is Abhilasha Sharma, and I will be your host for today. And the topic for our webinar is Introduction to Transformation Opportunities with Generative AI. So, in today's topic, we will be covering all the essential skills that are needed to transform and operate several tools or several techniques in generative AI. And let me introduce you our speaker for today. So we have Shubham Shankar, and he's a data scientist at InfoEdge. And he will be talking about transformation opportunities with generative AI in brief and explaining you everything. And before starting the webinar, I'll just tell you all that you can drop your questions and queries in the chat box. And I will be the connection between you and the speaker. So I will be putting up all those questions in front of him. So handing it over to you now, Shubham.
Yeah, thanks, Abhilasha. Yeah, hi everyone. So today we will be talking about the transformation opportunities that we have in the generative AI. So this generative AI field is now a recently booming field since the inception of ChatGPT in 2022. Since then, like a lot of research has been going on in this field, just like we were having innovations in the time of world wars where engines and different things were being made on such a scales. We are now having innovations in the generative AI field. So the scale is large. Daily, the technologies are changing. New things are coming up, and it's like a challenge to cope up with what is going on in the industry right now. And so it is like daily new things are coming up, and we have to understand like what are the things are changing. Large models are getting created, and they are like just increasing the capability of what machines can do. So as the core of this generative AI, there are a few basic things that must be there to like understand the advanced concepts that what are going on in generative AI. So in this session, the topics that I will be covering will be the most basic thing for this generative AI is deep learning and natural language processing. So in deep learning, it has been there for a few, like since 20th century itself, but its relevance is now becoming more and more important since these are the techniques which can handle large data. Then we have NLP, like how uh, text, images, or different things can be fed to machine, and a like human kind of capability is being built for can be built for the machines. Then we will be covering like what is happening in the generative AI field, like what are the foundation models, what are the fine-tuning techniques that we are doing, what are the different models that has already come up, what are the how we can basically use them in our workflow basically. Then we will be covering three advanced topics for generative AI, which are primarily used for image and video and basically a more complex things generation. So those are basically complex architectures like GANs, which is generative. These all are like generative techniques only, and we will be covering them as well. So starting with the first understand like what is basically AI. So if we are going to, if it's basically a branch of computer science where the aim is to impart the human intelligence to the machine. So all the development that is happening in generative AI comes in this artificial intelligence itself. So core to them, classical machine learning techniques where we were doing predictive modeling has existed since a long time ago. So in machine learning, so earlier what used to happen when simple softwares were made, they were based on rules, like rules had to be defined, and based on that, whatever machines need to perform the task, they were performing it. But with the emergence of machine learning, now through different predictive models, machines were able to take these decisions, but they were based on some simplistic tasks which we are using. Then came the deep learning. Deep learning was also there since long time itself, but the data that industries or in research that was used was not that large that deep learnings can be used on those data. But now since we are using these image data, text data, so these are bulks and bulks of data, like in image, like there are lots of pixels which we uh, need the machine to understand. So so for that, this NLP field came up where we were processing the inputs from the users, whether it's text, images, videos, or anything which can be matlab, how we want to communicate. So NLP has been like a core topic in which the recent developments in the field of data science or artificial intelligence is going on. So that is where all this generative AI and everything comes up. So basically, the prime focus is to uh, give inputs to machines which they can understand. So, like, see, we simply can't feed text and images directly to the machine. So we need their numerical representations, which machines can understand. So that is what NLP is. So we will cover all these topics in detail. Let's start with the most basic thing, which is deep learning models. So in deep learning models is something uh, which is which was created to depict the human brain. So in human brain, we have neurons. Here also we have the neuron techniques, neurons present. So all these neurons are connected to each other. And once these connections are established, the model is able to establish the relationships between different features. And so we are inputting a few features. Model is creating different hidden states. The more deeper these hidden states will get, the more complex this model will get, the better understanding it will be able to generate. But the issue with this is that we need enough data for it so that it can understand. Suppose we are just going on increasing the hidden layers, then it will not be helpful for the model if we don't have enough data, because with a large number of parameters that the model need to learn, based on which it will be taking up the decisions. If we are not showing up enough examples like how the decision is going to be made, then it will be difficult for a model to interpret this. So if we have large enough data, we can have deep networks. And if not, then going with the classical techniques are useful. But in image and videos data, as I've already mentioned, these are really helpful. So what happens here in deep learning, we feed the input data and we pass them through different hidden states. And finally, through different hidden states are combined through different weights. And so multiple hidden states they are passed through, and finally an output is generated. Once the output is generated, we already know what's the actual output should be. So we backpropagate this error or loss that we get through the generated output and the actual output, and backpropagate it into the model. And the model are able to adjust their weights based on this. So this is how basic deep learning concept is. Like, we are feeding the input, model is learning on the experiences, and when the new data or in real world when it will go, then it will be able to take decisions on whatever learning the model has imparted till now. So this deep learning is like a simplistic thing which you are seeing, but whatever generative AI innovations or different innovations that are happening right now all include these deep learning techniques, whether it's starting from simple ANNs, which are artificial neural networks, to convolution neural networks, which has been used in images, to sequence models. like RNNs, LSTMs, or even complex models of generative AI, transformers, BERT, GPT, everywhere these deep learning users of these deep learning models you will be able to see. So basically, that's only one challenge, that the data should be enough to use deep learning models. And just if you have enough data, you can definitely use or adjust the hidden layers based on that. Now going forward to NLPs. So the NLP, basic NLPs was started when we were just having a simple encoding techniques. So the main aim of having this concept of natural language processing is to understand whatever input we are giving to the machine, they are able to understand it through in their language. So machines can't understand text, they can't understand images. They will be only understand numerical representations. So that is how it was done. So the initials, when this technique was established, a simple encoding technique was used, which is known as one hot encoding. So in that, what used to happen, whatever new objects you have, you create a matrix of them, and whatever is your vocabulary, you just populate it with 1 or 0, whether this word is present or not present. Based on, so this was very naive kind of technique to generate the representation, but that's how this journey started. Then advanced techniques based on deep learning came up, where we were using word to vec. So in word to vec, we were also understanding the context of the words. Like if a word is below me, behind a word, then what is the context that word is adding to this embeddings. Then came even advanced embeddings, where like bot embeddings and that. So they were even able to capture long dependencies, not just 1 or 2 words dependency, but the context of the whole sentence was understood from there. So that was simple researches that was going around in the field of NLP. Then started a need of understanding sequences. Basically, understanding the sequences, the first few models that came up was recurrent neural networks and LSTMs. So the problem with RNNs and LSTMs was that the context window that it was able to take into the model was just one cell behind it. So those contexts were not enough to generate something or understand the full context of the sentence. Like last word or last few words can't explain everything that is there to understand this current word. Then came up new techniques, which are attention, self-attention. So in attention, what used to happen, that instead of just taking the understanding of the last word, we were combining all the uh, basically all the tokens of the sentence, and then we're generating the representation of a given sentence, given word. So that was also good, but then self-attention came up, where for each representation, for each token, where we were uh, predicting the representation of that token. So we were considering that token's influence of all the other tokens on this particular token. So that is what is being used in the transformer. That's the basic unit of transformer. So if you will see the architecture of the transformers, which is plotted here. So it has a simple attention layer. So it basically helps the model to understand like where on what tokens is the maximum dependency of this current token whose representation we are learning is there. So in transformers, there are two units. The first unit is the encoder, and the second unit is the decoders. So encoders basically understand the representation of the input that you are feeding. So its purpose is just to understand the representation. And once a context has been set, then it is fed to the decoder part, which is this second part. This will basically decode all the representations that we have learned through the encoders. So the difference between attention in encoders and in decoders is that in encoders, when we are generating the context for a given token, then we are looking the tokens which are behind the word current token, as well as which are in front of the current token, like all the, like we have of the full sentence, and then we are taking the learning the representation. Now, at the time of decoding the things, the future tokens won't be present, like tokens which are in front of the current token, they won't be present. So we will be just taking the context of the token that has already occurred. So for starting token, we will be taking the representation of what we have got through encoders. And for the rest of the tokens, we will be taking the attention for the encoders, the representation that we have got from encoders, as well as the tokens that have already, whose decoding have already happened. So that is how this encoders and decoders are working. So BERT and GPT. So these are like two different classes of algorithms. BERTs are basically based on purely encoder base. So there is no decoder part in BERT. So initially in 2010s, the more research was happening through learning a better representation so that the understanding becomes better and better. Now, since this generative thing is picking up, scientists are able to recognize key this decoder part can be a better technique to understand the text as well as generate new tasks. So this is a new field that is coming up very rapidly. So in generative GPTs, we are just using the decoder part. We are not using the encoder part. So whatever attention we are learning is through the previous tokens that we have already learned. So, and these transformers have a long use cases. It can be used for language translation, text summarization, in chatbots, information retrieval. Like in most of the places it can be used, and like the chat GPT or whichever algorithm which are currently popular. So these are all based on this decoder part itself. So that's the basic foundation of these all generative models. Now going forward to large language models or foundation models. So a lot of large models, like if you are going to use a simple neural network, so it will have around 1 million parameters, 2 million, 10 millions parameters they will be having. But these foundation models have parameters in billions, like 170 billion, 200 billion, 300 billion. And the recent models that have come up are having parameters even in trillions. So these are so a very large model. So they can't be trained on like simple machines where they require a lot of resources, lot of compute power. So big tech companies have come up with some foundation models which are trained on a large amount of data sets, on large amount of GPUs that was used to train this model. So they are basically the foundation models that we are seeing, like whether it's GPT or Llama. So these all models that have come up, which are trained on extensive data. The data set that they have used is from general resources, like they have used Wikipedia data, or they have extracted some books and they have trained on them. So on generic data, these models are trained. So they are able to perform generic tasks. And these generative models can use, and basically we can simply like suppose we have a chat GPT kind of a model, then we can use it to prompt we can simply design a prompt and help us do whatever task is needed to be done. So that's a simple technique. So with these foundation models we can do a lot of things. So with one example I've already mentioned is prompt engineering. Second example which we can do is we can do in context learning. So these generative models do not know, but they have simple understanding of the language that we have, but they may not be fully accurate in, like if we are just going to feed some random text to them and tell them to do some task, they may or may not be able to understand like how the output is to be given, how they are able to understand. So what we can do, we can show them an example. Suppose we are trying to predict the sentiment of a sentence, then we show them an example like this is a very good company to work. So, and write the sentiment is positive, and then give an example. He now predict what is the sentiment of this given sentence. So while prompting only, we can use these techniques to make the may help to do the task whatever is required. So these foundation models are basically can be used on multiple tasks, but they may or may not be too accurate. So instead of since they are generic models, so if we want them to perform certain tasks, then we can fine tune them on certain tasks that we want. Like we can fine tune them on single task or on a set of tasks. So depending upon our requirements, we can basically fine tune these foundation models. So pre-training, but the first part is the pre-training part, which is already done on good models. So if we are going to pre-train our own foundation models, so it will be difficult, like it will require a lot of compute resources, but we can use some parts of this. Like if we are pre-training BERT, then BERT have around 12 layers of encoders in them stacked. Each layer has around 17 million parameters. So if we are going to take the full BERT, then it will have around 170, 200 million parameters. But if you take a few blocks of this 17, if you take two blocks, like 17 plus 17, 34 million, then we can train 34 million parameters. Like this is a comparable size to deep learning models that we are already training. So we can even go for pre-training of these models on our own custom data sets. So they may perform better as compared to what these general models are going to perform on these data sets, on these tasks that is required for you. And but in like this is something which data scientists have to evaluate, like which technique is going to help them the most for their task. Pre-training can help. Even we can use these capabilities of these foundation models to fine tuning that I was mentioning. We can fine tune them on our task. So fine tuning is basically help us key. They already have the knowledge about English language and different contexts which they have learned through different examples that has been already shown to them while pre-training. And now we are just adding the context. Now perform these tasks. So it can have like we can do limited fine tuning. So fine tuning can be done in different ways. Fine tuning can be done key. Most of the parameters of the model are fixed and we are just tuning a few parameters on our task. So the parameters will be very, very small and can be even tuned on, like a toy model can be made even in Google Colab as well, where we are fine tuning only a few parameters. And fine up fine tuning can be done this one more technique that we are using is parameter efficient fine tuning. So there, what we are doing a simple uh, technique is LoRa there. So LoRa is basically a technique where we are creating a fine a matrix for fine tuning. So basically the weights of those matrix will only be learned and the actual matrix that we have for the model. So in them with a basically a parameter, we will be able to add that to the model. So the model will not forget what they have actually learned. It will just add their knowledge in this field. This fine tuning like should be done in a very uh, like it should be observed properly that fine tuning, if you are fine tuning on one task, the model, it will be like difficult for model to perform other tasks. So if like since we are tuning the weights, the model might start forgetting to do how the other task is to be done, but will perform better than better on the task on which the model was trained. So this is about basic LLM models that we have. So the examples, if you will look at some of the examples of the generative models that we already have. So GPT-1, GPT-2 have already existed since I think 2017 or 2020, they were already there. So major innovation that happened was GPT-3 came up in around 2020, I guess. And it has like 175 billion parameters. So the more the model's parameters are there, the better understanding they will be able to have. Then the biggest innovation which erupted this field was the inception of GPT 3.5. Basically, GPT, this was not a formal version that was released by OpenAI, but basically Chat GPT, it was like understood that Chat GPT was based on this GPT 3.5 only. So it was similar to GPT 3, but has much more capabilities. Like it was able to perform, it was able to generate text more in a more like meaningful way. Then came two models from Meta, which was Llama 2 and Llama 3. So they have parameters comparable to GPT-3, but they were made open source. So what we could do is we can use these models and train on our own tasks. When GPT-3, when ChatGPT or GPT-3 was there, their codes weren't made public and anyone was not able to use that. Just we had to just we were able to use only ChatGPT itself. Then this Llama 2 and Llama 3 was developed for the purpose of research. The model's performance was not as good as what GPT was, but it was still fairly comparable. And after fine-tuning on our specific task, it was performing better and better. GPT-4 came up in, I guess, 2024 itself, it came up. And so if you will see, GPT-3 has 175 billion parameters, where as GPT-4 is like 1.7 trillion. So it's 10 times greater. So the tasks that GPT-3 was able to perform, it's GPT-4 is much, much better on performing those tasks, understanding more and more uh, context about like how the task more efficient model basically it is. So GPT-4 is a very large model. So it's like downloading on the system and then fine tuning it. So it was practically impossible to fine tune this model. So GPT-4o was basically O stands for Omni. It was a lighter version of GPT GPT-4. So it has nearly all the capabilities of what GPT-4 has, and GPT-4o like can be used for fine tuning as GPT-3 or 3.5 is currently used. Then we have like in future GPT-5 can also be there, where it will have even more capabilities, have even bigger trillions or like very large amount of parameters they will be having performing all the tasks. Maybe they would be what limitations current this generative models have, they will might be able to pass all these things and we will be performing much better. We'll have like more ability to take decisions. Then we have multimodal models as well, where like in these models, like in GPT or Llama, we were only able to input the text, but in multimodal models like Gemini, so we were able to input text, images, audios, these kinds of inputs for us was also possible, and a single model was performing all these tasks. So basically, things are like becoming more and more complex as the research is going around in this field. So yeah, there are different kinds of generative tools present. So if you will observe, different kinds of generative solutions are present in the market. So these solutions are based on like different uses. Industries, some companies are basically fine tuning these models and then using it according to their task. Some companies are directly using these already existing foundation models, and just they are getting the whatever input they have and they are passing to these GPT-4 or some model, and they are just fetching the results from them and just returning it back. So some solutions are based on some very simplistic itself. So different kinds of solutions depending on the problem exists. So based on the usage, uh, mm, whatever technique is required can be used. So this was about mostly generating the text, well, like what is happening in the field of generating the text. So there are three more uh, uh, models that I will be discussing here, which are used for basically generating the images. So generating text is also a complex task. It's not an easy task, but as compared to generating an image, it's a much easier task. So here just we have to output the tokens of the words that we have. But to construct an image, we need to predict each and every pixel for the image. So it should be how the basically, and the position of the pixels. So everything matters here. So it's much more complex. The uh, dimensions of the input output are also much large as compared to what is there in the text. So there are three popular techniques. One is this generative adversarial networks, which are GANs. Second one is variational autoencoders, and the third one is diffusion models. The most advanced one is the diffusion models. So they are basically used in the image generation models that we have, which is DALL-E 2 of OpenAI or Sora. So they are so powerful, like they are even generating movies based on a given text or context is to be given, and they are just generating the movies on their own. So no shooting or nothing has to happen. They are just creating the characters and plot, and if the movie is generated. So talking about this generative adversarial networks, so it's an interesting kind of an algorithm that is that this GANs are. So in this there are two parts. One is the generator, and the second one is the discriminator. So the task of the generator is to take a noisy input and generate a output that is nearly similar to the output that is required. So it will kind of try to replicate the actual output that is there. But on the other task, on the other hand, the task of discriminator is to identify whether the image that was generated by the generator is real or fake. Basically, so the generator will try to fool the discriminator, and discriminator will try to catch the generator whether it has uh, generated the image right or not. So, so in this way, this model is trained. So the model learning finishes when generator is able to fool the discriminator. So in this way, so when this model is trained, once trained, we can use this model to generate duplicate images, or basically to replicate the images which are which already exist, like which means these can generate even images that has like have no sense, or like that does not have any meaning, like they can put the nose at the place of eyes, eyes at the place of nose. And so basically through this competitive process, these generators and discriminator will get trained. So these are used in image generation, style transfer, data augmentation. Second, when we go to the variational autoencoders, so first of all, let's understand what is autoencoders. So in autoencoders are basically takes input from the users, and basically reduce the dimension of the of the output. But the basically it's a dimensionality reduction technique where the same input is given and the model will try to predict the same output but with lower number of dimensions. Now how this technique can be used for generating something. So basically what will happen, we will input some information, whether it's text. Suppose we are inputting some text, the model will map it into a hidden state, and then will which is of much more smaller dimension, and then map it back to some original dimension. So suppose for generating the text, autoencoders basically can't be used directly as for generating something, because when we are mapping, suppose there's a vector is there of the text, we are mapping it into a hidden state and then mapping it back to the output state. So this hidden state is just a vector. So the latent space that this hidden state has is not very continuous. So it's basically it's basically discrete. So from discrete latent space, the model will never be able to generate correct output, like it will be outputting any noise or anything which is not right. And but once we in this variational autoencoders, what we do, like instead of mapping these vectors to another vector, we are mapping these vectors to a distribution. So basically each point of these vectors will be distribution. So it will be basically this so mapping it to distribution helps it make the latent space continuous. Now whenever a noise comes up, even if the noisy data is there we have, so the model will be through this uh, uh, basically representations, the model will be able to reconstruct the required output data that is required. So this continuous distribution helps us in generating the required output in a way. So these variation auto encoders are basically for basically altering the images if you want to do. So suppose we have like a digit prediction algo is there. So suppose we have a like number as 8 is written on an image and we want to change it to 6. So basically this will be a similar kind of image that is going to be generated, but the alteration is to be there. So the input will be that this 8 is to be converted to 6. So the variational autoencoders through different changes in the output distribution, hidden state distribution, it will be able to generate a 6 that is required. Now the third technique is the diffusion technique. So in diffusion, what happens, like this is the most advanced technique. So we start with a noisy data, like a lot of noisy data is there. And then with that noise data in each iteration, basically in each blocks, we will add more amount of noise. So basically this noisy data has to predict the original image that is to be there. So at the start of this diffusion model, there are two kinds of diffusions which is going to happen. One is the forward diffusion, and there was the reverse diffusion. So reverse diffusion will start with a noisy data and predict the more required output or well-defined resolution images are going to be predicted. And the forward diffusion is going to start from the original image that we have. It will add noise to each layer of the uh, an image that is going to be predicted in the next state. Kind of a Markov chain is going to be used in this. So start with an image, add noise to each of the images, and then reach a state where the noisy image will be present. Now, since the image is noisy and the distribution is basically continuous because random variables will be there, and then we are going to remove these noise again back in each step. So basically, this technique of removing these noise helps the model to understand how from a noisy information we will be able to generate the actual output that is required. So even if we input it or text, it will be able to understand that based on this text, this video or this audio or this image is to be produced. So these are basically very powerful in creating the images. So these techniques, this diffusion models is only used in basically in generating the image algorithm, advanced image algorithms that we have today. So in as I already had mentioned, DALI 2, DALI 3, and Sora, all these use this diffusion models itself. So talking about the future of the AI, so as the research and innovations are happening daily in this field, so it is very practical that more and more tasks we will be able to perform using the AI. Like AI is going to be uh, a powerhouse that will drive a lot of work that is happening in the industry or in research or everywhere. So it will basically affect us in day-to-day life, like whatever use and whatever things that apps or different things that we use currently will be integrating generative AI or some techniques of AI so that they can help users experience the platform in a different way. So some common or some sure things that are definitely going to happen with the help of AI, that is first will be the advanced AI assistant. So assistants will be present, which will be basically uh, we will be able to interact with the assistant, help let them do tasks is to be done. Like there are a lot of startups coming on this. Basically, they are helping us electricity that is there in our house. So that is basically controlled by them. Like they can switch on the light, switch off the light. So these kinds of techniques are going to become even more common. Then we can have autonomous vehicles where self-driving cars will be there. So it's already happening, but yeah, on a scale like especially in India, in the where the traffic is much more congested, and different kinds of nuances are there. So there also they will be able to predict the uh, outputs or obstacles more accurately, and autonomous vehicles can will be used in future. Then it can be used in robotics. Advanced robots will be made, which will be working just like humans are working today. Then basically, once this AI sets in, it will be ethics and governance will also come up. Like it should responsible AI should be there. Like AI should not be uh, creating harmful will should be generating harmful information or doing some harmful work which is not good for the society or environment. Then quantum AI is also going to be there now, since these AI generative AI models, and these have so many parameters. So with current techniques, these scaling these or using these models are very difficult. So it's like in ChatGPT 4 itself, like industries were not able to use that for their own task. So for that, quantum AI is going to be there, where compute will be really fast, and even more parameters models will be there based on this quantum AI. Then there will be personalization, as I was mentioning, key on different platforms. A personalized experience will be given to seekers, given to users based on their preferences and things. So there are lots of more innovations, like numerous innovations will be there in this field of AI. And like it's a field which will, like, learning about these fields will be really important. Like their matlab AI is going to basically facilitate human to do the task more efficiently or in a better way. So it's really good to understand how these techniques are working. So it's like some of the tools that are already present, like ChatGPT, so they don't require much technical knowledge. It can be simply used by anyone who don't have understanding of simple computer science theories, but they can be used. So such use cases, so basically understanding of how, what are things that can be done with this generative AI, like how it can be built, how it can basically, how we can alter it for our tasks. So these things, based on our use cases, we can use this generative AI in different ways. Yeah, so that was all from my side. So is there any question from anyone?
Yeah, so we'll be starting with the question and answer round now. And I think we have our very first question. So, the first question is how to mitigate biases in generative models, mainly in domains like healthcare and finances.
So biases in healthcare and these things. So basically, the data that is being used to fine tune this models. So basically, these are only going to help in, like, the better, the cleaner data that we have to train the fine tune these models will be helpful. We can even perform some techniques like reinforcement learning, as it is done in ChatGPT, where we are actually creating a environment and training the model, basically a human kind of human intelligence, how it performs. So the model will be imparting those those knowledge to the foundation models, the fine-tuned models that we will be having to them. So in this way, we can just handle these biases.
All right, so I have one more question. So, what challenges do researchers and practitioners face in advancing generative AI, and how do they overcome them?
Okay. So the biggest challenge, I think, will be the compute resources that we have. So basically, since these models are large, so it will not be practical to uh, basically the foundation model. Suppose the foundation models, if we are building foundation models, so it will be difficult to build on, like in simpler in general generic industries or in research as well. Like it requires like thousands of GPUs to train them, and lot of data is also to be created. Suppose if we are able to even create the data, but compute resource is something which is a big challenge. So there the work needs to be done. So yeah, that's why these simpler techniques which are fine tuning, so these have come up. So basically to facilitate this research and advancement.
All right, so there is one more question in the chat box that is appearing. Do you think generative AI will take jobs? If yes, what type of jobs in which sector and which industry?
Okay. So I think I don't think jobs will be taken away. New kinds of jobs or how the jobs are currently done, type of jobs are going to change. But yeah, uh, basically people have to upskill themselves with this generative AI techniques. As I was mentioning, we do not require to understand the full technicalities of generative AI. We just a non-technical person can also use these generative AI techniques. But yeah, the people who are going to use generative AI will be much more efficient as compared to people who are not going to use it. So yeah, it will not going to be change that it will not going to be take away the job. It will going to change how the current work is done.
All right, so there is one more question, I think similar to the previous one. Uh, and the person is asking that could you share any real world success stories or case studies where generative AI has led to significant breakthroughs?
Okay, significant breakthroughs. Okay,
Yeah.
so basically, generative AI is basically where, like, suppose like startups that we have currently. So earlier, the startups did not have like any uh, tool or any such repository where they could have extracted information or would have performed the task. But with the help of generative AI, now they are able to even do whatever they are planning. So they are able to do it with the help of generative AI. So it's simply they are integrating the existing generative AI and these open source models or existing GPT models, and they are able to uh, use for their use cases. So yeah, these are a lot of success is happening. So this is just a starting field where we are happening, where we are now even creating movies based on this generative AI technique. So yeah, that is not far where like generative AI will be performing better. So even in industries, if you will see like lot of we had to build different models for or different tasks that is to be performed. Now generative AI is single-handedly is performing all the tasks, which are like even better than the uh, simple models that industry people are using. So yeah, generative AI is booming. In a few years, it will definitely occupy a lot of uh, space in the market, and these stories will be there.
Okay, all right. There is another question. So, how to ensure robustness and journalization capability of a generative model across diverse data sets?
Okay, so basically, it depends on how you are fine tuning these models. So basically, if you are want to do the robustness of this model, so if you want keep the earlier information that these foundation models already have, we want to leverage that as well. So as I was mentioning in this LoRa techniques, where we are fine tuning based on like some parameters, like we don't want to fine tune all the like don't want to change all the weights, just alter a few percent of the parameters. Suppose 10% of the parameters are going to be changed. So in this way, like the robustness that generative model already has will be incorporated in that. And if generative AI is not have don't have robustness to the task that you want it to do, then you can create a data set which you can fine tune based on your task or requirements.
Okay, are there any more questions? I think that was it. If there are any more questions, do ask them in the chat box. And till that time, I am launching a feedback poll and it has been launched. So take a minute to fill this out. How do you felt about the webinar and what other topics would you like to be there from next webinar? Just fill this out, and in the meantime, you can also, if anyone wants to ask any question or has any doubt, you can drop it in the chat box. Also, take a minute to just fill out this ending feedback poll. I have launched it and it might be appearing on your screens. I feel that there is one more question. Let's take this one. This will be the last question for today. So, what challenges do researchers and practitioners face during generative when they have overcome the possibilities, and after that overcoming them, if they are still stuck in some problems, how do they overcome that?
Okay, so basically we are talking about uh, okay, so basically, suppose we are talking about, suppose just take an example for fine tuning. If we are fine tuning some model and based on our task that we want the model to perform, if the model is not performing according to the requirements, we can simply do different kinds of learning. So basically, if we don't have enough data, suppose we don't have the actual data that we want the model to feed. So we can do an active learning kind of a thing where we will be taking the outputs of the current system that we have, and based on some uh, human feedback or based on the model's scores or thresholds that the model is predicting, based on the some cutoffs, different techniques, we will basically differentiate the finer data, basically a cleaner data, and then feed it back to the model and again fine tune it. So this will help the model get more and more better at performing different tasks.
I think the attendee wanted to ask, maybe, according to my understanding, that if all the solutions that you are giving are
Mhm.
not working, so
Mhm.
what else can be done, like a backup plan, if there we are still stuck? So I think he meant that.
Acha.
Huh.
So I think this generative AI is like not like this, like we will not be able to create these foundation models. So if the model is not working, or like whatever solution, whatever problems that we are facing is not able, we are not able to resolve, then we will have to either use the techniques that we already have, or we have to fine tune, use prompts or different techniques. Otherwise, we will have to wait for the researcher. Suppose we want to create a film, basically Bollywood film that we want to create, but generative AI is not able to predict Indian people in that film. So like with current understanding, what we can only do is we can fine tune the models, change the weights, or do these things only. But for or like we can create a simpler model on our own self, or like I was mentioning earlier, basically we have to innovate there, like we have to create simpler models that will be specific to generating movies based on Indian characters. So that's how like we ourselves have to do something on in research, then only we'll be able to overcome this challenge. So yeah, it's a revolving field. Maybe while finding a solution to your problem, you might be in doing some innovation which will be helpful for the world.
Yeah, all right. I think that is it for today. And this was very enlightening session, Shubham. Thank you so much for taking out your time and briefing all the attendees about the topic. And we hope to have you back again in future sometime. And yeah, that's all for today. So we'll be wrapping up this webinar now. Thank you so much, Shubham.
Yeah.
And thank you so much, everyone. Do go on Shiksha Online website to look for further more topics and courses if you want them to be a part of the webinar. And do share your suggestions on our YouTube channel as well, that is Shiksha Online. And thank you, everyone. And thank you for being a part of this webinar. Thank you, Shubham.
Yeah. Thank you.